identities that are important enough for higher math that I think you need to memorize. Okay, we've already looked at every one of these identities before earlier in the class, so you want to make sure you know the reciprocal identities, the ratio identities, Pythagorean identities. Those things should look familiar to you, so you want to know those, along with odd, even, and cofunction identities. Okay, those things you're required to memorize in this class. Those things show up quite a bit in higher math, so you want to know those. Now, one thing I gave you tonight to pick up was this identity list, and this will pretty well give you all of the identities we're going to learn this semester. When we get into our third test, remember we do the third test instead of a final in here, I will basically give you anything that doesn't have a star by it. So I'll give you like the double angle identities, I'll give you the half angle identities as well. In Calculus 2, you end up using the half angle identities quite a bit, but for this level of a class, I'll be giving those to you. And then I want you to also memorize the sum difference identities, and we'll be looking at those Thursday night. Now, the reason that we like students to memorize so many of these is because we know we're going to use it in a calculus class. So you want to be able to get most of these things up here so you can use them when you need them, because you'll use them a lot in Calc 1. Okay? So the first thing I'm going to do is we're just going to work with some identities, and we're going to simplify expressions before I get into proofs tonight. Okay? So the first thing I'm going to do on this is I'm just going to look at these identities, and we're going to play with this a little bit and just kind of see what happens on this. Okay, and then we're going to try to algebraically simplify this a little bit. Okay, so first of all, what I'm going to do on this is we have the identity secant is 1 over cosine. So I'm going to have you just replace that with 1 over cosine x. Okay, and then 1 over secant, if you look at your identities 1 over secant, notice up here you have 1 over secant is equal to the cosine. And you end up doing this kind of thing a lot in calculus when you're working with derivatives or integrals. You end up working with identities quite a bit when they show up. So we're going to do that. Now what we're going to do is get a common denominator, simplify this, and take this as far as we can. All right, so all I've done is applied two identities and change those. Now what I'm going to do is get a common denominator. So between cosine x and 1, the common denominator is cosine x. So I'm going to have you multiply the top and bottom by that. Okay, and that's going to give you 1 over cosine x minus cosine squared x over cosine x like that. Okay, now when you put this together, since we have a common denominator, we would have 1 minus cosine squared x over cosine x like that. All right, you guys understand what I've done so far? Now, I'm not done. We want to take this as far as we possibly can. If I want you to simplify, I want this to be down to as few symbols as possible. There's one other thing we could do, and that has to do with this identity right here. That's the Pythagorean identity. So at the side, I'm just going to write down sine squared x plus cosine squared x is equal to 1. So notice in this problem, we got 1 minus cosine squared x. You can take this identity and rearrange it so you have sine squared x equals 1 minus cosine squared x. So in other words, what we're going to do is we're going to replace this with this. Okay? So what we're going to do is when you see 1 minus cosine squared x, that's the same thing as sine squared x over cosine x like that. Okay? So I did that. Now I still want to take this a little further. I can take this still a little further. One thing you could do is you could split this up so it says sine x over cosine x times 1 over cosine x like that. Okay? Nope, that's totally wrong. What am I doing there? This is times sine x like that. Okay? Then I'm going to take it to this level. So I'm going to do this. Okay? What is the sine over cosine? If you don't know it, look at my identities up here. That's tangent, right? So if you look at this identity right here, sine over cosine's tangent, so we're going to end up just having the tangent of x times the sine of x. Okay, we've got that down to two trig functions like that. Now, when you're working with these things right here, I think when you're doing this on your homework, Most of these things are kind of multiple choice, so it sort of helps you to know when to stop. Because the purpose of this activity right here is just learning how to manipulate trig identities to rearrange this in a different form. In calculus, you'll usually kind of know where you're trying to go. So this is also sort of preparing you for the proofs that we're going to do. So you want to just try to take that as far as you can, all right? Sometimes it's pretty obvious to know when to stop. Sometimes it isn't, okay?
So why wouldn't you just leave it as sine squared x and you would take it out?
Just because, and see, that's what you get into. It's just what I'm seeing, and what I want you to get you to see is when you see sine over cosine, then you can change that into a tangent. Okay, it's not, it's almost ambiguous. Which one is more simplified? Well, that's kind of a judgment call, but generally we want to get it down to as few trig functions as possible, no exponents, just down as far as we can. So this one is, in my mind, a little bit simpler than this. Okay, that's why I did what I did. Okay, so on the next one, what we have is we have cosecant of x times sine of x plus cosine of x. So again, we're going to multiply it out and we're going to simplify using whatever identities we have. Okay, so I'm going to have you do a distributive property. So when we do that, we're going to have cosecant of x times sine of x. And then if I do this, I'm going to have cosecant of x times cosine of x. Okay, like that. And then we'll see how far we can take this. So I've got cosecant x times cosine of x like this. Okay? Now there's several things you can do. You don't even necessarily have to write all these steps. What is something that you know about cosecant? That it's 1 over sine, right? Okay. So we have the identity that the cosecant is 1 over sine. Okay. And again, if you don't have your identities memorized, you can kind of look at them, refer, and you have to try stuff on these problems too. Okay. Then I'm going to do the same thing with this. I'm going to change this cosecant to 1 over sine x like that, just leaving the cosine alone like that. All right. So notice what happens. That cancels out, leaving you a 1. This right here is a cosine of x over a sine x. So if you look at your identity list, what is cosine over sine? Cotangent, right? Okay, so we've got that. So if you look at your identity up there, so you've got cotangent is cosine over sine. So what you would get on this then is a pretty simple answer, 1 plus cotangent x. So we got it down to where now we just have one trig function, and we only have, just a few symbols in there. So that's probably about as simple as you're going to take that right there. Okay? So I'm taking identities, substituting equals for equals, then trying to simplify that as far as we can. Okay? Okay, let's see. This one right here. Now, there's a couple of approaches to the next one. Okay, I'm going to show you two approaches. Okay, and one might be a little better than the other. One thing that you might be thinking is, what is sine over cosine? That's tangent. What's cosine over sine? Okay, that would be one approach, okay? I think that you could probably make it a little simpler than that, though. Okay, so what I'm going to have you guys do is this. We're going to get a common denominator, and we're going to take it this direction. Okay, so what would be the common denominator on this problem? Sine, cosine, right? Okay, so what you need to do is this one needs to have a sine in it. So you're going to multiply this by sine x over sine x like that. This one needs to have a cosine, so I'm going to multiply it by cosine x over cosine x there. You've got to do the same to the top and bottom. Okay, so if I do this now, notice what I'm going to have is this fraction right here is going to become sine squared x over sine x cosine x. This right here is going to become cosine squared x over sine x cosine x like that. Okay? All right, so now what I'm going to do is this. I'm going to combine that into one fraction. So I'm going to get sine squared x plus cosine squared x all over sine x cosine x like that. Okay? What else do you notice, if anything? Yeah, right. Okay, this is 1. Okay, sine squared plus cosine squared x is 1. So you have 1 over sine x cosine x. Okay, what can you do with 1 over sine? What is 1 over sine? Cosecant. What's 1 over cosine? secant, okay? And you can do this in your head, but you're really looking at 1 over sine x times 1 over cosine x. So that's cosecant of x times secant of x. Okay, the thing on this is, I want you to realize, like when you're doing your homework and stuff, you will be guided through because the problems are kind of, usually they're multiple choice. Okay, because to me, which one's simpler? That's a matter of judgment. So to me, either way, to me is an acceptable answer. Okay, the whole point behind this is, can you take an expression and work with identities to rearrange it in some way? You'll kind of see the purpose of this a little bit more when you get in a Calculus 1 class, okay? Because there's reasons why you do these things, okay? Okay, so let's do a couple more of these. I want to mostly spend the second half of class working on identity proofs. So let's go ahead and see what we can do with this one then. So we have sine x plus cosine x to the second power, and then we have 1 plus 2 sine x cosine x like this, okay? So let's see, with this one, what do you think would be a good suggestion? Multiply out the top, yeah, okay. You probably would FOIL it out, right, and just see what happens. Now, when you're working with these things, sometimes you have to try stuff, okay? I can't teach you a procedure that's always going to get you to where you want to go. You have to just kind of look at the problem and say, okay, well, I'm going to try this and see where it leads me. So I'm going to write this as sine x plus cosine x times sine x cosine x. And you can do the foiling in your head. I don't care if you do that. It's good if you can do that, okay? Okay, so I'd end up having this then, okay? All right, so I'm going to go ahead and I'm going to multiply out the top. So I've got first term, sine times sine is sine squared x. Okay, outside term is going to be plus sine x cosine x. So I think I kind of know where this one's going. Inside term is going to be plus sine x cosine x. And then the last term, cosine times cosine, is plus cosine squared x. And then I'm not going to do anything at all with the denominator. I'm just going to leave it like that. Okay? Now, the other thing is, these are like terms, right? So that's going to give a sine cosine plus another one is what? 2 sine cosine. So what you'd end up having next is you would have sine squared x. I'm going to write this like this. Sine squared x plus cosine squared x. I'm going to put it in this order, although ultimately it makes no difference. So I'm just going to write that like this and see if you see what I want you to see. Okay, so what do you notice about this right here? That's a 1, right? So that whole thing is going to become 1 plus 2 sine x cosine x like that. Okay? I think I left something off of there, didn't I? So this is, I didn't bring this down. That should be a cosine x. Wasn't typing that right. Okay? So anyway, that would be, right there would be 1. So you've got 1 plus 2 sine x cosine x over 1 plus 2 sine x cosine x. So what's the answer to this problem? 1. Yeah, now that's as simple as you can get. Okay? There's no doubt about that. Okay? So sometimes you work them out and you'll just run right into something very, very simple. Sometimes you may have 2 or 3 approaches that get you to kind of equally simple answers. That's the idea. Okay? All right, let's do one more here. Let's finish up 6 and 7, then we'll take a break, and then most of the second half of class we're going to devote to proving identities. The purpose of this activity is mostly to prepare you for that. Okay, so on this one, I'm going to kind of take this the same direction. I have 2 tangent x, and then we're just going to FOIL this out. Okay, and you can apply that shortcut if you want to, or you can just write it out and FOIL it out like that if you want to. Okay, one thing I want to mention right now while I'm thinking about this is you could have gone from there to there just in your head. So the shortcut is square the first, that's sine squared x, square the last, that's cosine squared x. If you multiply those together, you get sine cosine. Then what do? You double it. So if you've got that shortcut down, it saves you a little bit of time, so you can just do that shortcut. Okay, so that's what I'm going to try to do on this problem, is just do that shortcut on this. So if you did the shortcut here, when you square this out, you would have 1 squared is 1. You take the tangent and square that, you get tangent squared x. Then you take 1 times the tangent of x, and then you double that. Okay, so that's what you would end up having. It's just 1 plus 2 tangent x plus tangent squared x. That's real helpful for higher math, that you can square binomials in your head. So again, it's just 1 squared, tangent squared, multiply together and double. So you get 1 plus 2 tangent plus tangent squared x. That's what you're going to get if you FOIL it anyway. So I don't care which way you do it. Just want to make sure you do that correctly. Okay, so that's going to give 2 tangent x. Now I need to have a big parenthesis or grouping symbol. The result of that would be 1 plus 2 tangent x, and then plus tangent squared x like that. Okay, I'm going to distribute that negative through the parentheses, so I'm going to get 2 tangent x, and just change all the signs like this. So I'm going to have 2 tangent of x minus 1 minus 2 tangent of x minus tangent squared x like that. Okay, so what do you see happening? 2 tangents cancel. Okay, so that's good. So it looks like what we're going to have from here is that's equal to negative 1 minus tangent squared x. Okay, now I'm not going to give up on this because I have one other thought on this problem. So you have an identity that goes like this. Okay, one of your identities is tangent squared x plus 1 is equal to secant squared x. Okay, that's one of your Pythagorean identities. So I just want to see if this makes anything simpler. It may or may not. So what I'm going to do is I'm going to do this. I'm going to move the 1 to that side to get tangent squared x is equal secant squared x minus 1 like that. So what I'm going to do, and just see if it makes any difference on the problem, is I'm going to change that tangent to this. Okay, and just see if it gets me down to a little bit simpler level. Probably doesn't matter that much on this. So if I do that, I would have negative 1 minus, now replace that tangent squared with secant squared x minus 1 like that, because I'm thinking something was going to cancel out. So what I'm going to have is negative 1 minus secant squared x plus 1. 1's cancel out. So in my mind, that's less symbols. So that would probably be as simple as you're going to get that right there. Okay, so that's the idea. When I see a tangent squared in there and I have a 1 in there, that's what makes me think about this identity right here. Okay, so you want to take that to that point. And again, I can think of when I teach Calc 2, when we're working integrals, we do this kind of thing all the time when we're working with integrals of trigonometric functions. So the better you know your identities for calculus, the better off you're going to be. Okay? Okay, well, let's go ahead. Let's take a break here, 10 minutes, and then we'll wrap up this part when we get back, and then we'll do the proving identities to finish up here tonight. Proofs of identities, okay? So let's see, number 7. Okay, what you want to do with this one is you can do some of what I'm going to do in your head, but it's not a bad idea to write this problem out as cosecant of x times cotangent of x times 1 over secant x. Okay, I mean, you don't have to do that. Like I said, you can do this in your head, but just kind of split it apart. So if you're doing that, you're taking the fraction and splitting it apart. And then what we want to do is we just want to think about identities. Okay, what's an identity for, I'm about to tell you, what's an identity for cosecant? What have we used a couple of times tonight? 1 over sine. Okay, let's just try it. Remember, you just got to try stuff. Okay, so let's try that as 1 over sine. Okay, what's an identity for cotangent? There's either 1 over tangent. What's another one? Cosine over sine, right? Okay, let's try that one. Okay, now again, sometimes you'll try something and it won't help, so you just try something else. So let's try cosine x over sine x like that. Okay, what's an identity for 1 over secant? What's that equal to? Cosine. Okay, so that would be equal to cosine. Okay, so we'll have cosine like that. So that's what I'm going to suggest you try. Okay, with practice, you'll go in the right direction a little bit more often than not. So then what I'm going to have is I'm going to have cosine squared x over sine squared x like that. That's what I got. Now we can take that further because remember cosine x over sine x is equal to cotangent of x. So what you could do is you could change this to cotangent squared of x, okay? And that's about as simple as you're going to get that. It's got one trig function, and then you got it made, okay? So that's as far as you can probably take that, okay? So again, I'm just applying the basic identities, simplifying, and seeing how far I can take it down, okay? All right, is there any question about that, what I did there? Okay, all right, let's see what we can do on this one. Now, this one right here, if I look at this, I have a couple of thoughts. Now, what you have in these problems is it's normal when you're learning this to go in the wrong direction. So one thing that you might think is get a common denominator. Okay, that's probably not incorrect to do that, but I have a slightly different thought. Okay, so what I'm going to do is I'm going to split this apart. So I'm going to have you write this as sine x over sine x, and then minus cosine x over sine x. Okay, all I'm doing is if you have a fraction and you have one or two things added or subtraction, you just split it apart, right? That's the opposite of putting the fraction together. Why did I do that? Well, here's my thought. What's this? 1. What's that?
Cotangent.
What? Cotangent, right, okay, so that's my thought. I just sort of saw that. My original thought was common denominator, but I think it's probably a little better if you do this way. Okay, then we're going to do exactly the same thing with this. We have plus cosine x over cosine x, and then we have minus sine x over cosine x like that, all right? So we got that. So then what we're going to have is sine x over sine x is 1, cosine over sine is cotangent x, cosine over cosine is 1, sine over cosine is what? Tangent, okay? So I get this, so what I get is 1 plus 1 is 2, so I get 2 minus cotangent x minus tangent x like that, okay? And that's one direction you could take that in. If you did a common denominator, I wouldn't be surprised if you ended up with something in a little bit different direction, and you might be able to get something that's equally simplified to that. So that's just a thought that I had on that, okay? Okay, let's go to the next one. The next one I'm going to look at the same way. I'm going to just split this apart, so I'm going to write this as 1 over sine x, and then minus cosine x over sine x like that, okay? All right, now if you know your identities, you'll do this one very easily. What is 1 over sine x? What?
Cosecant.
Cosecant, good, okay? Cosecant x. If you don't know your identities, start working on memorizing them. Okay, what's cosine over sine? Cotangent, okay? That's as simple as you're going to take that, okay? So that's the idea, is just kind of get that down to a little bit simpler form, all right? Now what we're going to do, the main thing is getting enough practice of this will help you when you deal with this in a calculus class, because a lot of times when I teach calculus, I see students really weak with their trig identities, and it really impacts how well they can learn certain things like derivatives and integrals. So the next activity is mostly preparing students for that idea, okay? But we're also going to be doing what we call verifying identities. So what you're going to be doing with this is you're going to be showing that something's equal to something else. Okay, so an example of an identity would be this, and this is kind of what I want you to use as a guide for how I want your work to look like when you verify an identity, okay? So what we're going to be doing on this, I'm not going to go through the proof of this. I just want to use this as a model of what your work needs to look like. So what you're trying to do is you're trying to show that this thing is the same as this. You don't really know if it is, so the purpose is to show it. So what I always want you guys to do when you do an identity is just write down proof, and then you pick the most complicated side. That one is a lot more complicated than the right side, okay? So you just write down the left side, and then you write down an equal sign. That's how you always want to start your proof. Don't start it any other way. Pick a side, write it down, and write an equal sign. I'm not kidding about that, because students really develop really sloppy habits when they do this. And you want your work to go straight down the paper like this. And you want to just keep going until, boom, the other side pops out. And it doesn't pop out like magic. Sometimes when I'm grading these problems, I'll see all this stuff, and wow, magically it pops out. Okay? What I want to see is that every step is correct, okay? Because I got to grade it, like a grade of proof. So it's just like, okay, if everything's valid, then I can tell that you're doing that right. But I always want your proofs to look basically like that, okay? All right, so that's the idea. Now, what I've done on this is I've given you a couple of pointers. Again, write down the side that's more complex. Keep writing the equal signs down your paper. And then eventually, you just kind of substitute identities for identities until the other side comes out. These are some general pointers that you can look at. We'll kind of talk about these as we go. One thing that's helpful a lot of times is to write your expression with nothing but sines and cosines. That's very helpful sometimes, okay? So we'll be doing that sometimes as we do that. Okay, so we're going to do several of these tonight to just kind of begin to get the idea here. And what we'll do on this is I want to do one thing on this real quick before I start into this too. So one thing that might help you a little bit as I'm going over this is you've got a list of identities. You picked up that identity sheet, so you might kind of have that at the side of your paper right now as we're doing these proofs. So what you want to do is, once you get these memorized, you don't have to look at these so much, but as I'm teaching this, I like to generally kind of go through and refer to the identities as I go through these. Okay, so here's what you want to do on problem 11. This is probably a real simple proof. Sometimes they're very simple. They take like 2 or 3 lines. Sometimes they take a whole page of paper. Okay, so step 1, which side is more complicated to you, the left side or right side? Left side's got 2 things. The other side's got 1 thing. Okay, it's usually a little easier to take something complicated and simplify it than it is to do it the other way around. So what I'll have you do is write down the most complicated side and write an equal sign. Please start your proofs that way and don't do anything else, okay? So now what we're going to do is we're just going to see what we can do with this, and sometimes you don't overanalyze it. You just look at your identities. Okay, you have a cotangent. What idea do you have for a cotangent? Look at my identities if you need to. What?
Cosine over x.
Yeah, let's try cosine over sine, okay? So let's replace that cotangent with cosine theta over sine theta, and you got to have your theta there, guys. I see this all the time from students. Cosine over sine is meaningless. Okay, you got to have, I always say this, if you have a sine without an argument, then you have a sin. Okay, all right, so you must have that argument in there. You can't just have sin. That doesn't mean anything. Okay, it's got to be sine of something. So don't be lazy about stuff like that. Okay, do you have any ideas for me on a secant for an identity? What? 1 over cosine, okay? That's exactly what I was thinking. Is a secant is 1 over cosine. So you want to replace that with 1 over cosine theta like that. All right, now bring your equal sign down. Now what do you see happening algebraically on this problem? Cosines cross out. Write down what you're left. You've got 1 over sine theta. Keep writing that equal sign down. What is 1 over sine theta? Cosecant theta. There you go. That's exactly the way your proof needs to look, is that we just did substitutions and then that side popped out. Okay, that's exactly what you want to do, is go straight down your paper. If you have to do any scratch work, just do that at the side. I want to see everything clean so it's easy to follow. Okay, that's important to learn how to do that. So that one, see, just took 3 steps. Sometimes they're going to take a lot more than that. It depends on the situation. Okay, so let's go to this next one here. And with the next one, which side is the most complicated, you think? Well, the left side. It's got more stuff, okay? It's usually easier to go that way than the other direction. So again, the way I would want you to start this out is just to write down the most complicated side. So that's cosecant squared u minus cosine of u times secant of u, and then put an equal sign. So you just want to start it that way. Ultimately, we're going to try to see if that turns out to be the other side, the cotangent, okay? Now, what you got to do in these problems is sometimes you don't overanalyze. Sometimes you just try stuff, okay? When you get experience with this, you'll start getting better at this. So I see a cosecant squared. Okay? Are there any identities that have a cosecant squared in it anywhere? Okay, I have a sneaking suspicion that that's what this proof is all about. Okay? Now this thing right here, do you guys know what cosine times secant is? I'm just curious. It's 1. You may not know that. Not all students know that until they practice this a little bit, but it is. Now you can do this. This is optional. It'd be okay if you just turned that into a 1 because that's really a form of an identity. Let's go ahead and just do this like this though. Okay, so let's just change the secant to 1 over cosine. Now it's real easy to see that it's 1. Okay, so I'm going to have you write down cosecant squared u minus 1 like that. Now you can bypass that first step. You can go from there to there. I don't mind that. That's fine. Okay. Now you've got several ways to write this. What I'm going to do is I'm going to replace that cosecant squared with this thing right here. Okay. Again, I substitute equals for equals when I'm proving identity. So the idea is I'm going to do this. This is the same as this. Okay. So bring down the equal sign. Don't lose that equal sign. Keep bringing it down. So you're going to have 1 plus cotangent squared u minus 1. Okay, what happens? 1's cancel. What are you left with? That's what we were trying to prove. Okay, that's it. See how beautiful and elegant that proof was. Straight down the paper. Everything was logical. One thing led to another like that. That's a four-step proof. So we're going to start off with some of the simpler ones here tonight. That's how that's going to go. All right. Okay, any questions so far? Okay. All right, now on this one right here, it's kind of, which one is the more complicated side is debatable. I'm pretty sure you could get this to work either way, but it probably would turn out on this one that it's a little bit easier to work with the left side. Okay, but you can always try, and when you're proving identities, sometimes you will try something and you'll fail, and that's when you just have to wad up your paper and try something else. So you do have to try stuff on these problems. Okay, so what I'm going to do is let's write down the left-hand side, cosecant u minus sine u, and then put an equal sign like that. Okay, and again, don't try to be over-analytical on it. Just try to think of stuff and just take an idea and run with it. What's something I could do with cosecant? What's an identity? What? 1 over sine. Let's just roll with it and see what happens. Okay? So go ahead and replace that with 1 over sine u, and then we'll just keep the other sine u the way it is. Okay? You don't want to change the other sign to 1 over cosecant because then you're not really making any progress on the problem. So the next thing I'm going to do is put that over 1, and I'm going to go ahead and get a common denominator. The reason I know to do that is because the other side of the identity does not have any fractions, and it's not 2 fractions separately. So I've got to put those things together. So the common denominator is sine u. So what are you going to do with this second fraction? Multiply by sine u over sine u. Okay, so we're going to do that. Okay, and you need to show that on your paper like that. Now the next step, bring it down. We'll have 1 over sine u minus, and then that other fraction is sine squared u over sine u like that. Okay, so we got that. So we've accomplished getting our common denominator. Now put it together. So we have 1 minus sine squared u over sine u like this. Okay, and then there's several ways you can approach it from here. Okay, at some point in the problem, you want to start thinking about what you're trying to prove. Okay, so when you see a sine squared, does anything jump out in your mind immediately? Any of those identities? If I see sine squared, what jumps out? I hope something. This one right here, right? Okay. So you can rearrange that. One thing you can do, and you don't have to show this, you can do this in your head. If you move the sign there, you would get cosine squared as 1 minus sine squared, right? So that thing can be replaced with cosine squared. You don't have to show that on your paper because you want to manipulate and rearrange these identities in your head, okay? So the idea on this is this part right here is just going to be a cosine, right? So what we're going to do in the next step, then going straight down the paper, is we have cosine squared u over sine u like that. Okay, now let's look at what we're trying to prove and see what kind of progress we're making. Okay, you have to have a cosine. Is there a cosine? Yeah, you have to have a cotangent. Is there a cotangent hidden in there somewhere? Yeah, where is it? Cosine over sine. Okay, so yeah, what you want to do on this step is write this like this. It's pretty easy to see, but I want you to just break this up so you have cosine of u times cosine of u over sine u like that. Okay, and you don't have to have everything precisely like I have. You could have stuff backwards and stuff. So anyway, that's cosine u. Cosine over sine is cotangent of u, and that's what I'm trying to prove. Okay, so just by doing equals for equals using basic identities, I've shown that that's the same as that. Okay, and again, that's the way I want everything to look on your paper, is just straight down like that. Okay, sometimes you'll work through these pretty easily. Sometimes you have to play with it, and it can be kind of a challenging thing to do. All right, does everybody follow what I did on that okay, you think? Okay, all right, let's take a look at the next one. And let's see kind of what we have on this one. So this one I'm going to work with, I'll just work with the left side. I suspect this one wouldn't make a lot of difference which side that you focus on. So I'm just going to go ahead and write down the left side, which is cotangent squared x plus cosecant squared x, like that. And let's see what we can do with that. Okay. So let me kind of show you what my thought process is on this. So I do kind of think through these as we go. All right, I'm trying to prove that this is 2 cosecant squared x like that. So I'm kind of tempted to leave that alone. We've already got a cosecant, so I'm not going to do anything with this. Now look at cotangent squared. When you look at cotangent squared, what identity pops out at you, hopefully? That one right there. Okay, so you're going to rearrange that identity. So what you have is you can replace the cotangent. All you got to do is move that 1 there, right? So you would end up having cotangent squared is cosecant squared minus 1. Now again, you don't have to show that on your paper. You want to do that in your head, okay? Or scratch paper, just kind of rearrange that like that. Okay, so what I'm going to do is I'm going to use this identity. That identity right there is just saying cotangent of x is equal to cosecant squared of x minus 1. Again, you don't have to show that on your paper, so I'm going to replace this with this. Okay, what I'm going to get on that is I'm going to get cosecant squared x minus 1. I'm going to leave this second cosecant alone, and like really fast, this one's proved in like 2 steps. Those are like, whoops, did I write something extra on there? Yeah, that shouldn't be there, so that we have that. Okay, so again, I changed the cotangent to this, left the cosecant alone, so I'm going to end up with 2 cosecant squared x minus 1, so that shows that the identity, that we verified that. Okay, see, that one was super easy. Okay, all right. Okay, let's go to these next here. Now, these are the ones where you start getting into some fractions, where they can get a little bit more difficult. So what I want to go ahead and do on this then is let's do a proof on number 15. Okay, so we're going to write the word proof, and the side that's more complicated is pretty obviously the left side. So let's write down 1 minus what is that? Cosine squared u, 1 minus cosine squared u over 1 minus sine u like that. Write down an equal sign. Okay. Now, what we got to do on this is we got to kind of, again, look at our identities here. And if we look at our list of identities, let's see. What do you think? Any idea about how I might start this? Just what you tell me. I'm curious what you think. I see a cosine squared u. What does a cosine squared u make you think of? Hopefully it makes you think of this identity, right? Let's just play with it. Don't overanalyze it. Just try stuff. The more you write down, the more it'll kind of guide you through the paper. So yeah, this identity right here is really just saying that cosine squared alpha is 1 minus sine squared alpha. Okay, so what I'm going to do is I'm going to change that cosine squared to 1 minus sine squared. You'll do that so much that you'll just do that in your head. So I'm going to write this as 1 minus, and now change the cosine to 1 minus sine squared u. Make sure your variables are correct. All over 1 minus sine u like that. So I changed that to that. Okay? All right, so we're trying to show that this is negative sine u. So any other thoughts about what might be next?
Split of diffraction.
What's that?
Split of diffraction.
It's not a bad idea, but I don't think it'll get you anywhere. Okay, and you would know that if you tried it. So it's a thought you have, you roll with it. Anything else?
Can you cancel?
Not yet. You can do something before you cancel.
What's it condensing?
How about this thing right here? 1 minus sine squared x. Okay, what if you have 1 minus x squared? Isn't 1 minus x squared a factoring problem? It's a difference of 2 squares. Okay, that right there is a difference of 2 squares, so you want to factor it. What you're going to get into when the problems get a little bit more complicated, you're going to have to factor from time to time. So bring down the 1, bring down the 1 minus sine u, just leave that alone. Okay, now what we're going to do here is we're going to go ahead and we're going to factor that numerator like this. Okay, so when we do this, we're going to draw 2 parentheses. How does it factor? 1 and 1, sine u, sine u. How do the signs go? Plus minus, there we go. Okay, when I heard you say canceling, yeah, you can now, but you have to factor first before you can do that. Okay, so what's going to happen is this entire factor cancels with that. So let's write down what we're left with. We have 1 minus parentheses 1 plus sine u like that. Okay? All right, now we're getting closer. So now what we do is we just can take off the parentheses. You'd have 1 minus sine u. The 1's would cross out, and you've got what we're trying to get. Okay, so that's the idea. Okay? So the thing with that is you would have to think about using that and do the factoring. The other thing that you could have done, and different students are going to give me different proofs. Another thing you could have done is put that over 1 and got a common denominator, and I'm pretty sure the same thing would have happened. Okay, so it's just you can go through different ideas and prove these things in different ways. Okay, all right, you guys follow the logic on that? Okay. Okay, don't forget about factoring. That's kind of a big deal when you're dealing with these problems. Okay, if I go to 16, which side is more complicated? It's pretty equal, don't you think? So here's my thought process on this. To me, if you have a secant, it's pretty easy to change a secant into a cosine by changing that to 1 over cosine. Now, it wouldn't really matter which side you start with. So I'm going to start with the right side. That's just my decision, but it would work either way. So let's write down, we have proof on this, and then what we have is we have secant theta minus 1 over secant theta plus 1. Okay? Now, about all you can do, and with this problem, you're going to start off by making it look a little bit more complicated, but I'm pretty sure eventually it'll work out. Okay? So what I'm going to do is I'm going to use this identity right here. The secant is equal to 1 over cosine. So we're just going to change this to 1 over cosine theta minus 1 all over 1 over cosine theta plus 1 like that. Okay? Now it looks like we're making things more complicated. Yeah, we are. But the next thing is, we've seen this semester. This is called a complex fraction. You want that cosine to go away. You don't want it to be there. So how do you make that cosine go away? You multiply by cosine, right? You multiply everything in the top by cosine and everything in the bottom by cosine. That will get those things to cross out. So what you would want to write on your paper then is just this. Okay, I'm going to take this whole numerator and multiply it by cosine theta, and I'm going to do exactly the same thing in the denominator because I have no choice. Okay, so now look at this. I've shown you kind of how to do this in your head. So you're doing a distributive property. So if you take cosine times that, what's going to happen? What's that going to leave you? That's 1, right? Because that's going to cancel out. What is this going to be? Minus cosine theta. Do that in your head. You don't have to show anything on your paper. That's going to be 1 minus cosine theta. The bottom is going to be 1 after they cancel plus cosine theta like that. Okay? And that may be what we're trying to prove anyway. I think it is. So if I do a distributive property, you're going to have 1 minus cosine theta. And then if you go to the bottom, you're going to have 1 plus cosine theta. That's what we're trying to prove. Okay? That one worked out to be actually fairly straightforward. Okay? And you could probably do that the other way. You could have started with the left side, and you could have done it just exactly the same way. Okay? All right, let's see what we got going on here. Most of these have been pretty straightforward. I just kind of randomly picked these out of the book. So this one here kind of has the look to me like it might be a little bit more challenging to do, but I don't know until I try. So what I'm going to do on this is, it's pretty obvious the left side is the most complicated side. So I've got 1 minus secant theta over tangent theta. So you want to go ahead and get that left side written down. Plus tangent theta over 1 minus secant theta like this then. Okay? Now there's a couple of approaches to working this problem out. Let me just kind of tell you what different thought processes you might have. Okay, you could get a common denominator. That might be one approach to the problem, is just get a common denominator and see what happens. When I look at that, that might be a reasonable idea. Another thing I could do is I could change the secant to 1 over cosine, and I could change the tangent to sine over cosine. Now I'm going to do the problem that way because a lot of times what you're going to do on My Math Lab, they'll guide you through the proof, so they will say change everything to sines over cosines. That's a general strategy that usually works well. So what I'm going to do in this step is I'm going to use identities on those 4 things right there. So what I'm going to have you do is change that secant to 1 minus 1 over cosine theta, like that, and then we're going to write that tangent as sine theta over cosine theta like that. Okay, then on the other side, we're going to change the tangent to sine theta over cosine theta, and then all over 1 minus 1 over cosine theta. So what I did is I changed those pieces just using the fundamental identities like that. Okay? Now this is a thought. This is one thought I have. I can think of a couple of ways you can go about doing this problem. Okay, so what's the next thing that you would like to accomplish?
Multiply the whole thing by cosine?
Yeah, each one. Now you got 2 individual things. So you want that cosine to go away. So you need to multiply this fraction by cosine over cosine and that one too, and just see where this leads us. Okay? All right, we'll find out where it leads us here in a minute. Okay, so what I'm going to do is I'm going to take this fraction and I'm going to multiply that by cosine theta over cosine theta. I'm going to do the same thing with this fraction. I'm going to take the whole thing and multiply that by cosine theta over cosine theta like that. Okay? And again, process this in your head so you don't have to write all this stuff out. Okay, if you block this off, what's this going to give you? Cosine minus 1, right? Everybody see it okay? You go to the bottom, what's that going to be? Sine theta. Okay, if you go here, if you do the numerator, cosines cross out, leaves you sine theta. You go to the bottom, you have cosine theta minus 1 after the cancellation. Do that and process that in your head, and then just write down what we have. Okay, so what that's going to lead us to is cosine theta minus 1 all over sine theta. So that's what we get there. Okay, now if we go to this next one, that'll cross out the cosines there, leaving you sine theta. And then the bottom is going to be cosine theta minus 1 like that. Now we haven't done much of the problem. It almost looks structurally like the original does, but a lot of times it's easier for students to work with sines and cosines than it is other trig functions. So what I'm going to do now is I'm going to get a common denominator on this problem. Okay, so let's write down what we have. What is the common denominator going to be? Sine theta, cosine theta minus 1. It's both of them, right? So we got to introduce that. So let's bring this down and let's get our common denominator and let's see where this leads us then. Okay, so what I'm going to do with this is I'm going to multiply this by I want to take this part right here. I'm going to multiply that by sine. Oh, hold on. I need a cosine theta minus 1 here. So I'm going to multiply this part right here by cosine theta minus 1 all over cosine theta minus 1 like that. Okay, so I'm introducing that common denominator. What are you going to do the other fraction? Sine theta, sine theta. So I'm introducing a common denominator in that problem. Okay? All right. Now let's see where this leads us when we do this now. Okay, so by doing this then, we're going to multiply all this out. So you're going to multiply this out. See, that's FOIL, so you need to do that, and then you need to multiply that out. Okay? Just leave the denominator factored. So when I do this, I'm going to multiply out this numerator right here. I'm going to FOIL this out, so that's going to be cosine squared theta, and then minus cosine theta, and then minus cosine theta for the inside term, plus 1 all over sine theta times cosine theta minus 1. And then I go to the next part. That's going to be sine times sine is going to be sine squared theta. And I'm going to write this just in the same order. You don't have to do that, but I'm just going to choose to write that in that order, kind of like that then. Okay? All right, so this one's getting a little bit, complicated with all the terms we have in here. So now what I'm going to do is I'm just going to bring this down. This is like terms there. So I'm going to bring that down and just write this as cosine squared theta minus 2 cosine theta plus 1. And we can go ahead and get a common denominator now. We can go ahead and put this in one fraction. So I'm going to go ahead and bring down the sine squared theta. Then I'll have sine theta over cosine theta minus 1 like that. Okay, so what I've done is I've got my common denominator, and I've got this in one fraction. All right, so here's what you want to kind of think about here. Okay, there's a negative 2 in your answer, right? Well, the negative 2's popped up, so I kind of sense like we're in the right track here. What do you notice about the numerator, if anything? There's something I hope jumps out at you. Yeah, sine squared plus cosine squared is 1. Okay, you don't have to explain that. You just replace that. So what I'm going to do is this thing right here is going to become a 1. So I've got 1 minus 2 cosine theta plus 1. And then in the bottom on that, I've got still got sine theta times cosine theta minus 1 like that. Okay, so I'm getting closer. Okay, so now what I've got is these are like terms. 1 plus 1 would be 2 minus 2 cosine theta all over sine theta times cosine theta minus 1. Okay, this problem is getting, see, this one's going to be one that takes up a whole page of paper. It's just the reality. Okay, now, any thoughts about the numerator? Ultimately, we're trying to turn this into just negative 2 cosecant theta. So I have a sneaking suspicion something needs to cancel out. What do you think? I'll tell you what I see right now. I see a negative 2, and I see a sine theta in the bottom, okay? 1 over sine theta is cosecant theta. So what's something you can do in that numerator? If you want something to cancel, what you've got to do. Before you get it to cancel, we did that a minute ago. No. Begins with F. Factor, not FOIL, factor, okay? All right. So it's factoring. Factoring is a big deal on these problems, okay? So we can factor a 2 out of the top, right? That has a common factor of 2, so take it out. So we'd have to write this next step like this. Take the 2 out. So you'd have 2 parentheses, 1 minus cosine theta, all over sine theta times cosine theta minus 1 like that. All right, looks like we're getting closer. Now, let me ask you this. I don't know if we've seen this much this semester, even at all. I don't know. Are these things the same? 1 minus cosine theta minus 1. Are they the same expression? No. They're backwards. So what you can do is you can turn one of them around, and if you do that, that introduces a negative. So what you're going to have is it's up to you. What I'm going to do is just change this one around. Okay, and what you have to do is this. So this is really 2 times cosine theta minus 1 and then you put a negative in front. Now, you don't have to write it that way. You can put that negative in front of the 2 if you want to, but you need to understand why that is. So you have a negative cosine, and a negative 1 is a plus 1. So if you change the order you subtract, well, you got to put that negative in front. Does that make sense? That's a real crucial step in this problem, is you have to show that. Okay? And then what we have from here is the denominator comes down. We have sine theta times cosine theta minus 1. Now they cancel. So what I did is I changed 1 minus cosine theta to negative cosine theta minus 1. That's a common thing that you have to do with problems like this. Very common in algebra that you have to simplify like that. Okay, now let's see what we got left. Now what we have left is we're left with that negative. We're left with a negative 2. So we've got negative 2 over sine theta. Now what in the world are we trying to prove? Negative 2 cosecant theta. Okay, do you see how it works now? What's 1 over sine? 1 over sine is what? Cosecant, right. So now you got it proved, and you can just write the result now. You don't have to write this next to the last step, but you could technically say negative 2 times 1 over sine theta. You can bypass that if you want to. Now you can just say negative 2 cosecant theta, and that proves it. Okay? Now see, that's what you can get into sometimes. That took almost like 10 steps probably to get that proof done. There's probably another way to do it that might be a little bit simpler. If I played with it a little bit, I might be able to come up with something. My original thought was to just get a common denominator at the start, but I do want to give you an example where you change everything to sine over cosine to finish up your proof. That's what I'm going to do on this next one. Okay? So what I want to kind of do to finish up is I'm going to start you off on number 18, and then I'll just give you a few minutes to see if you can complete it. Okay? And then on your written assignment, before I let you go, I want to just mention a couple of things about proofs and the way that you want to write these things out. So I'm going to start you with step 1 on this, and then see if you can finish this up. Just give you a few minutes to see if you can do that. Okay, so let's write down the most complicated side. That's cosecant theta plus cotangent theta all over tangent theta plus sine theta, like that. Now what we're going to do on this is we're going to do kind of the same thing we did in the last problem. We're going to try to change everything so it has sines and cosines in it only. Okay, so what should I do, you think, with the cosecant theta? 1 over sine. Change that to 1 over sine. How about the cotangent of theta? Cosine theta over sine. Good. Okay, and then go to the bottom. How about the tangent? Sine over cosine. How about the sine theta? Should I do anything with that? No, because what I want you to do is have everything written in sines and cosines. Now I want you guys to see if you can finish it up. It's a complex fraction, so you got to deal with that. Take a few minutes and see where you can go on this problem then, okay? Go for it, and you'll know if you're doing it right, if everything is working out and you end up ultimately with cosecant theta cotangent, then you got it right. So go for it and give it your best shot, and let's see how it goes. Did this or not. The only thing that you would probably want to do here is, what do you need to multiply by to get rid of all these fractions? Sine cosine. Okay, so you had to have done that. If you don't multiply by both, you're not going to get rid of both. So we're going to multiply top by sine theta cosine theta. Okay, like this. So if you got past this step, that's the next thing to check. Okay, so if you distribute, that would cancel the sines out, leaving you cosine theta. And then if you multiply this by this, the sines go away, giving you cosine squared theta. So you got to make sure you got that first of all. Sometimes students have a problem visualizing all that all in your mind. What I try to get students to do on this is block that off. That cancels, leaving a cosine. That cancels, cosine times cosine is cosine squared. Just try to block stuff off in your mind. Now, if you go to the bottom, if you do this like this, if you block that off, cosines cancel out, so sine times sine is sine squared. And then this is going to be sine squared cosine theta. Okay? So you want to make sure that you get to that point, okay? So this is going to give you sine squared theta plus sine squared theta cosine theta. Did anybody get to there? Okay, good. Okay, that's a major hurdle that you got to get past. If you're not getting that, is getting rid of those complex fractions. Okay, now, how would you factor the numerator? You can take a cosine out. Good. So you take a cosine out, and you would have cosine theta, and then what inside? 1 plus cosine theta, right? Okay. How do you factor the denominator on this problem? Take a what out? Sine squared. You got to take a sine squared out. Highest exponent. Okay, take a sine squared out. When you take out that sine squared, you're going to be left with 1 plus cosine theta. Anybody get to that point? Okay, what happens? Yeah, that cancels out. I like that. So now we've got down to the point where we have cosine theta over sine squared theta. Now you've made it down that far in the problem. It's a good idea now to look and see, what are we trying to prove? Okay, do you see a cotangent inside of this expression? Is there a cotangent hidden in there? Yeah, there's a cosine over sine. Is there a cosecant hidden in here? Yeah, you got 1 over sine. Okay, so what you want to do is you want to just break this up like this. Okay, so you'd write this as cosine theta. Doesn't matter what order you put this in. I'm just going to try to match it with how this goes. So I'm going to write this as 1 over sine theta times cosine theta over sine theta. Now we got it made, because 1 over sine is cosecant and cosine over sine is cotangent theta. Okay, now your proof doesn't have to look precisely like that, but those are kind of the key steps that you go through to do that problem. So to me, probably just from my observation, probably a lot of you didn't get rid of those fractions correctly. That's what I would predict. Okay, so probably